Hello everyone, I'm Lee. In this video, we are going to focus on another ADT in this project called entry list. And class entry list is trying to model a list of entries. So the public interface includes the two constructors. One is the default one and another one takes in a file name and initialize your list with the data on that file. And we have a bunch of accessor functions for list. For example, get will say, if you give me an index, I will give you back the entry at that position. And search entry says, if you give me a name, I'm going to give you back a match. And I will return true for that. If I return false, don't even look at this match because it's going to contain garbage. And the get size will give you back the actual number of address entry objects in this list, not the capacity of the list. And print all will print everything to the standard out, and the save address book will save whatever in this list to the external file. And two mutator method or two mutator functions. One is to add one entry, so this one will append to the list, and this one will load the data from this file and populate the list. So that's the public interface of this ADT. And to implement this ADT, I use an array, and at this moment we don't have much other choice. We don't have many other choices. We can only use array. So this is an array, and we are all familiar with. And this size isn't the capacity. That's an actual number of address entries in the list. So now let's take a look at the implementation. For the constructor, the default constructor, we want to say the list is empty. That's how we say the list is empty. And another one, we initialize size with 0, then we load it from address book. How to load from address book? The algorithm is almost identical to whatever we had in the previous version, the version A. So we open the file, we read in one entry at a time. But here, when we try to set up the entry, we ask the entry object to do it. So that's the address entry object to do it. Then we invoke the add entry. Okay, and the get size is trivial. So that's about the implementation. You can see when we implement this data type, it's all those functions, they work with this data. So they either access it, they either initialize it, access it, or trying to modify it. So those functions provide a public interface for this data type. So now let's take a look at the client of this ADT. So this time, we don't have array anymore because we don't have to worry about array. We have a nice ADT called entry list. And we don't even know if it's implemented by using array or some other data structure. So we just create an object of that list and using the second parameter, which takes in a char array as a file name. So now we create that object. Then when we say process command, we pass in the command and we pass in this nice object passed by reference because it could modify this object. And before we leave, we save the address book. And how we save it? We ask, let's say, please save address book. Okay, now let's take a look at the process command. So for add, if you want to add a reading entry, that's the same. Then you ask list, say list, please add entry. I will give you the entry and you are going to add it to this nice list object. So you see in the previous version we have the array, we have to do the add by ourselves. And now we just ask this list, say, hey list, please add this entry to you. And similarly, when we need to print out all the entries, we ask list, please print out all the entry. And here ask list to search the entry and do things for us. So that's from the client's point of view. From client's point of view, all you care about is what can this ADT do after I create the object. So you care about the public interface because the private part, anyway, you don't have access to it. So you don't need to worry about it. That's a good thing because later when we do our future labs, we're going to modify whatever's here. And you will see the client code doesn't need even to be touched because we only rely on the public interface. And this is not their business. And in object-oriented programming, we have the first rule is mind your own business. So every object, they manage their own data. And when you interact with the object, you only care about the public interface. You don't care about the entry list.cpp because that's implementation detail, and you don't care about the private data members because that's implementation details again. Thank you.